test is on Wednesday, and I'm gonna quickly go over most. Then the multiple choice, I want to go over the math problems, make sure that you know how to do them. Couple of things that did go wrong. This should not say Illinois. This should say California. So how much California? Um, how much energy was produced, or which one were the ones that was produced the most in Illinois in 2023? It is based off of the four here. So although a lot of people are like, oh well, natural gas is the most, but that's not one of the options. So which one of the options produced the most? And that would have been solar with 19.2. Which one produces that, or which one of these would represent the total energy? And then again, this is for California. The sum of wind, solar, hydroelectric, nuclear, and natural gas, and geothermal. Those are the ones that actually have numbers, and that's why that would be how we would figure out the total output. When it comes to biomass, geothermal, and petroleum, California doesn't produce any petroleum, so that would not give us total energy. And then solar and wind, well, those are only two of the ones that have numbers. And nuclear plus coal, I think coal is 0 for California. How would the frequency of rain near a hydroelectric dam and its reservoir affect the energy produced by a hydroelectric dam? If there is more water, then there is more mass. And so, based on the equation, if there's more mass, then there's going to be more potential energy. So we can produce more energy. The one that's correct, if you start looking at these, it's like sun, wind, home. It doesn't go straight home. Sun, home, cell phone, wind turbine, no. Sun, wind, turbine, to power lines, to the home, to the cell phone. So this one's C. With wind energy, what would happen to the wind turbine if the wind moved faster through the turbine? More energy is produced because there's more moving energy. Therefore, there's more kinetic energy. On the back side, here we are looking at, in which figure above, the nuclear plant sends 45 joules of electrical energy to the transmission line. How much work was done by the nuclear power plant onto the transmission of the lines? If the nuclear power plant is sending 45,000 joules, and we're assuming that no energy is being lost, then conservation of energy, and because work is equal to the change in energy, and because of the conservation of energy, then we can say that it has to be equal. The other question says, a very similar, but now it's 32,000 joules of electrical energy that's feeding into our lines, but there's friction. If there's friction, we're going to have to do more work to overcome the friction. So more work, because friction causes heat, and that is one of our useless energies. Well, not useless, they warm up our food, but it's not going to go back into electrical. It's just going to be heat. Which of the following statement describes how solar power plants shown above work? So we look at the solar system. The majority of the energy enters via uranium. No, the majority enters through the sun and leaves via the power lines. Number 9, which of the following statements is true about energy? Energy is not created or destroyed. Energy can only be transferred or transformed from one energy to the other. And then for this one here, you're going to try to find the total energy. So you want to add and then figure out your number there. I actually am at home and I don't have a calculator. I thought I did have one here and I don't. So I'm going to leave you with that piece. And then on this back side, for standard 2, I want you to be able to show your work for this. So calculating the kinetic energy of the skater. At the top, it says a 75 kilogram skater is at the top of a half pipe and about to enter the ramp. The skater is initially moving at 10 meters per second onto the 8-meter tall half pipe. The skater drops to the very bottom of the ramp, 0 meters above the ground. You need to be able to solve these two problems like this. So up here, we're starting with 10 meters per second. If he's 10 meters per second here, he's going to be going faster here. So faster as he rolls down the pipe. So potential energy, 75 kilograms for both of these. G is 9.8 and the height is 8. PE equals mgh. So when you put these on the calculator, especially for the kinetic energy, 0.5 times 75, 10 is the only number that is squared. This should give you an answer of 35, 70, 38, 70. Okay, I'm using my cell phone calculator. Here goes. 0.5 times 75 times 10 squared, which is 100. So our answer is 3750 joules. So notice I actually squared the 10 ahead of time. And also because I don't know how to square on this. Oh, here, maybe. There it is. That's my square for this and my square root. So I guess I'll just do it like this. And then for the potential energy, your mgh, 75 times 9.8 times 8. 75 times 9.8 times 8. So this is going to be 5,880 joules. So calculating the total mechanical, to calculate total mechanical energy, we're going to use that equation that says KE plus PE. And if this is the equation we're using, we need KE and we need PE. So bringing the numbers from up here, 3750 joules and 5880 joules. So our total mechanical energy is 3750 plus 5880. which will give me a total mechanical energy of 9,630. And if this is my total mechanical energy, I have to remember that this number is going to be the same at the top of the ramp as at the bottom of the ramp. So that amount of energy will not change. That's why it's the conservation of energy. However, the potential energy is going to change. In this case, if we're at the bottom of the ramp, there is no height at the bottom of the ramp. Any number multiplied by 0 is going to give me a 0. I'm going to show you the algebra. If you want to just explain, that's fine. But make sure you explain or else I can't give you the points on the exam. No height. If there is no height, there's no potential energy. Calculating the kinetic energy at the bottom, do not use 10. The velocity is not 10. Velocity is not 10 meters per second. That is at the top, not at the bottom. So you cannot use this number. Then you have to look and see what other equation has KE in it and I can use. And then remember that the total mechanical energy is going to be the same at the top of the ramp and at the bottom of the ramp. That's why I can find my potential energy, or my kinetic energy, sorry. I was writing potential here. With that in note, KE plus PE, we know that this number is 0. So if 0, then we could even take it off the equation. So that means that the total mechanical energy is equal to the kinetic energy at the bottom of the ramp. So all of the energy, both kinetic and potential at the top, has transferred to all kinetic at the bottom. So this is my kinetic energy at the bottom. How does the energy transform? The total mechanical energy does not change, but the potential at the top transforms into kinetic energy at the bottom. That is your big link here. And now you can find the velocity because you have the kinetic energy. So my little guy didn't lose a leg, so I know that he can have his 75 kilograms, and KE equals 0.5 mv squared. So now we do some math here. 9630 equals 0.5 times 75 x squared. So 1/2 of 75 is going to be 37.5 equals 9630. Divide 9630 by 37.5. Now I have 256.8 equals x squared. And now take the square root of that number. And our velocity is 16.02 meters per second. On to the back. Which of the following has more gravitational energy? More gravitational energy, PE equals mgh, has to do with height. So whichever one has higher point will be the answer. Which of the following will decrease the gravitational potential energy of an object? Decreasing mass, decreasing height. Oh, increasing mass, no. Decreasing speed. Speed doesn't have to do anything with the potential energy equation. So again, we're looking at these variables. So it has to do with decrease. So then we are getting less height. Which of the following will increase the kinetic energy of an object? Kinetic energy has to do with mass and velocity. Velocity will be the one that affects it the most. Okay, so which of the following will decrease kinetic energy? Not increasing mass, not decreasing height, but definitely decreasing speed. And then the largest increase of kinetic energy would be anything related to the velocity, because in the equation, velocity is squared. So anything that has to do with the velocity, tripling the velocity would be the one. The rest of the problems are work problems. So how much force would you need to push a distance of 15 meters for work done at 100 joules? Work equals force times distance. So 100 equals F or X times 15. Divide 15 to both sides. So 100 divided by 15 will be our answer. What is that, point something? 100 divided by 15, 6.67. How much work is done on a car if it's moved 19 meters with a distance of 14,000 newtons? Work equals force times distance. 19 times 14,000 equals X. Don't have any algebra to do, so I feel like people get stuck when they see the X here. This is already solved. You have nothing to do other than multiply these two numbers. That is my students when they mess up this question. I worry because it's like you already solved the problem. You have to divide nothing. Just multiply the two. Work is in joules. And the last one, how much force do we need to push a distance of 4 meters and do work with 1300 joules? Work equals force times distance. We're looking for force. Or you could write 4x, so 1300 divided by 4. Is 325. Alright, you have the whole review guide. In this video, it was 20 minutes, so fast forward, watch it several times, do whatever you need to do. But test is on Wednesday.